All right, well, if we're going to figure out the hybridization of a molecule, so this is we're going through the Chemistry 1 Honors Midterm Practice Test. If we're going to figure out the hybridization, we have to first figure out what kind of bonds are involved. Okay? So, what? Oh, it's not on the overhead. Okay. And we have sulfur dichloride. Is that correct? Is that correct? We have sulfur and chlorine, sulfur dichloride. So we're going to have two chlorines. So I go to the periodic table. I figure out how many electrons I have around sulfur and chlorine. Sulfur is right here, and if I count from the left, you get 1, 2, 3, 4, 5, 6. So I need 6 dots around sulfur. 1, 2, 3, 4, 5. And since it doesn't matter which sides I pair them up on, I'm going to pair them up like that because that'll leave me some electrons for sharing toward the chlorines. Okay. Chlorine is over here. It's in this column here, and if you count across, it gives you 7. 1, 2, 3, 4, 5, 6, 7. Actually, I should be doing it like this: 1 on each side until I've put 1 on each side, and then I can start pairing them up. Okay. So there's the electron dot formula. Then I know I can look here and I can see pretty clearly I can share there, and I can share here. Okay. And that'll give me a sharing arrangement. Then I can put them together and get an electron, a Lewis dot formula by squeezing the electrons I've shared between the two atoms. So these electrons get squeezed in between, and I'm squeezing these two in between down here at the bottom. Okay, and there's our Lewis dot formula. Okay, all right. I don't really have to go any further to figure out hybridization. Okay? The only hybridization that will give me this arrangement is sp3. And here's how I know. These shared pairs of electrons, okay? These shared pairs of electrons form a bond that's directly in a line between the sulfur and the chlorine. If we were doing a three-dimensional, or if we were drawing the shape of the bonds, okay, they would be, let's see, sulfur might be here, and I'd have a sigma bond going to the chlorine. Okay, so it's directly on a line between the two nuclei, and this sigma bond here is going between here and this chlorine. Okay, directly on a line between the two atoms. All sigma bonds are the result of hybrid orbitals, sharing or overlapping. Okay, all sigma bonds are the result of hybrid orbitals. Sulfur's hybrid orbital overlapping and sharing with the hybrid orbital from chlorine. Okay, lone pairs. These two lone pairs over here are also the result of hybridized orbitals. Okay. So if we're doing this, we would actually have to show the one in front, one behind, because it's a kind of a tetrahedral arrangement. Okay? Lone pairs. When we're doing the Lewis dots anyway. Lone pairs are the result of hybridized orbitals. And the only hybridization that has 1, 2, 3, 4 hybridized orbitals is sp3. Okay? So if I I hate to even mention this because it allows you to figure it out without understanding why. If the number of sigma bonds, because they come from hybridized orbitals, plus the number of lone pairs equals 4, then this is an sp3 hybridization. Okay? But you need to understand why. The why is sigma bonds can only occur after you hybridize an orbital. The only orbitals that occur, the only kind of bonds that require unhybridized orbitals are pi bonds. Remember, those come from unhybridized p orbitals. You remember that? I don't see anybody's head going up and down. I'm really disappointed. Okay. Because I've been working hard to try and teach this stuff. I feel like I've failed you guys. I'm going to cry. All right, I see more heads going up and down. Thank you. Okay. I just want to make sure you're listening. What? For those listening to the recording, I'm really just kind of playing around with these guys. They know that. You might not. What?